Hey everybody, my name is Matt Collins and I'm a math teaching pastor. In this series of videos, we're going to explore the pre-algebra topic of fractions, factors, and exponents. Hey everybody, this is the first part of our series on factors, fractions, and exponents. And today we're going to talk about factors and prime factorization. Hey, before we dive in to learn how to do these things, there are 5 terms I want to make sure we understand. Those 5 terms are factor, prime number, composite number, prime factorization, and factor tree. These 5 terms are going to be so instrumental in understanding how to do these problems. I want to make sure you know how to do them. Well, first, let's talk about what a factor is. A factor is a number that multiplies into another number. For example, 3 is a factor of 6 because 3 multiplies into 6 evenly. Factors are usually considered whole numbers. They're not fractions or decimals. They're considered whole numbers, and they multiply evenly into another value. Another example might be 5 is a factor of 30. Because 5 multiplies evenly into 30, or you could think about it backwards, 30 is divisible by 5 evenly. Next term we want to talk about is prime number. Now a prime number is a number that only has one set of factors. Prime meaning one, mean only one set of factors. Only one and itself multiplies into it. So we can think about the number 3. 3 only has one set of factors. Only 1 and 3 multiply into 3. But 4 has 3 factors because 1 goes into it, 4 goes into it because 1 times 4 is 4, but also 2 goes into it. 2 times 2 is 4. So 4 is not a prime number, 3 is a prime number. But number 24 is a composite number. A composite number is a number that has more than one set of factors. So 24. 24, you can divide it by 1, because every number can be divided by 1. You can divide it by 2, 2 times 12. You can divide it by 3, 3 times 8. You can divide it by 4, 4 times 6. And those are all the numbers that are factors of 24. So 24 has factors of 1, 2, 3, 4, 6, 8, 12, and 24. The number 24 has 8 factors to it. So it's called a composite number because it has more than one set of factors. So far, we've talked about what a factor is, what a prime number is, what a composite number is. Now, the next term we want to talk about is factor tree or prime factorization. Now, a factor tree is a diagram used to find a prime factorization. Now, let me talk about how to do a factor tree first. Now, any number can be divided by other numbers. Sometimes only one goes into it, but other times you can find other numbers that go into it. Now, let's go back to prime numbers since we're doing the prime factorization or a factor tree. Now, we use a factor tree to find all the prime numbers that make up another number. So, if we thought about the number 24, we talked about that already. If we thought about the number 24, we could make a factor tree out of that. The factor tree would be 24, and then 2 times 12. 2 is a prime number, so I circle it because that's the end of that branch on that factor tree. And then 12. I look at 12, and 2 goes into 12, so 2 times 6. I circle 2 because that's a prime number. 6. 2 goes into 6 as well. 2 times 3. Now I've gotten 2 numbers that are prime numbers, so all the branches are closed. I got 2, 2, 2, and 3. So this factor tree shows me that 24 breaks up into 2 times 2 times 2 times 3, which is 24. Let's talk about what prime numbers are again. Prime numbers are numbers that only one and itself go into. So, 1 is part of the definition of prime number, so it's not considered prime. 2 is a prime number. 3 is a prime number. 5 is a prime number. 7 is a prime number. 11 is the next prime number because 9 is divisible by 3. So the prime numbers so far, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. That's the first 10 prime numbers. For most of the stuff that we're going to do in this video, and probably you in your 8th grade class, that's as high as you're going to have to go. All right. Hey, in a section that deals with factors and prime factorization, you're going to be asked 3 major types of questions. The first is to determine whether a number is a prime number or a composite number. Now, to figure this out, you just have to see if any other number other than 1 goes into that number. So any even number is composite. Any number divisible by 3 is composite. Any number divisible by 5 or 7. And you can actually run through the prime numbers to figure out if any of those numbers go into the number you're looking into. So if the number is 26, it's even, so 2 goes into it, it's composite. If the number is 51, it's not even, so 2 doesn't go into it, but 3 does go into it 17 times, that makes it composite. But 53 does not have any numbers that go into it other than 1 and 53. So that's an example of a prime number. That's the first type of problem you'd see in any homework dealing with factors and prime factorization. The second type of problem you might see is to draw a factor tree for a number. Now, I always use the smallest prime numbers first. That way, my prime factorization is automatically in numerical order. So if it's even, I start with 2. If it's not even, I look at 3. Then I look at 5. Then I look at 7. And I just look for the smallest prime number that multiplies into that value. And then I keep going down, just like we saw with the number 24. So when we do a factor tree, I circle the prime numbers because that branch is done. And I keep dividing the numbers up until I cannot do that anymore because all I have left are prime numbers. And then finally, I'm going to use a factor tree to write the prime factorization of a number. So now that we know how to do a factor tree, and we'll do an example of this in a moment, but now that we know how to do a factor tree, writing down those factors with a multiplication sign in between is how you write the prime factorization. And if you want to be really fancy, you can do multiple factors as exponents. And we'll see one of those in a moment. Okay, everybody, I want to close going through one example that shows all of what we've talked about. All right, let's write the prime factorization of 72. So 72 is a composite number. It's even, so we know 2 goes into it. So when I do the factor tree, I'm going to write 72 on the top. I'm going to branch off from 72, and 72 is 2 times 36. I'm going to circle the 2 because that's a prime number. 36 is still even, so 2 times 18, circle the 2. 18 is still even, so it's going to be 2 times 9. And I circle the 2, and then 9's not even anymore, but I know 3 goes into it. 9 is 3 times 3. So if I looked at all the circled numbers in my factor tree, that gives me the prime factorization of 72. So 2 times 2 times 2 times 3 times 3. Those are all the numbers when multiplied together that give me 72. The prime numbers that multiplied together give me 72. 2 times 2 is 4, times 2 is 8, times 3 is 24, times 3 again is 72. So I can write this down as 2 times 2 times 2 times 3 times 3. Or, if I want to be super fancy, I can write this down as 2 to the 3rd power, because there's 3 2's multiplied together, times 3 to the 2nd power, because there's 2 3's multiplied together. All right, you should be all set to work on any homework that deals with factors and prime factorization. Good luck.